talking about the plasma membrane of the cell. Okay, so here's the cell, and you see this picture I have, the blue area is the area around the cell. We call that the plasma membrane, or cell membrane, you may hear it called that. And the membrane is made up of fat molecules. And there's membrane outside the cell, but there's also membrane inside the cell. We call it the endomembrane system. And all this stuff you see there is surrounded by membrane too. There's the walls of these different organelles are all membrane. All the brown stuff there and the purple stuff and right here and all these little vesicles and vacuoles. We're going to talk about these things. It's all made of membrane. And the membrane consists of what we call phospholipids. Phospholipids, you remember the fat molecules we studied?
Yeah.
The lipid molecules? Y'all should already know what these lipid molecules are made of. Do you remember?
Absolutely.
The parts that make up a lipid molecule?
Absolutely.
This is called glycerol. This is glycerol. And what are these called?
Fatty acid chains.
Fatty acid chains. So if you take a glycerol and you stick one straight saturated fatty acid chain, one unsaturated fatty acid chain, stick a phosphate group in another group, there you have this molecule. It's called a phospholipid. Phospholipid. And the phospholipid molecule is represented in this picture, and they show it on the top of page 188. Look at the top of page 188. This, see, it has a circle and two legs. Looks like a head and two legs.
Yeah.
That's this. It's a fat molecule, a phospholipid. Now it's interesting, the phospholipid has two areas on it. It has an area right here, the tail part. We say that the tail part here is non-polar. Can y'all guess from your past classes what that means?
It's not magnetic.
It's not polar.
It's not magnetic. It's not charged. Very good, Meredith.
I said.
And because it's non-polar, we say it is hydrophobic.
That was Meredith Mosley, by the way.
Hydrophobic means afraid of water. Doesn't like water. The tail parts hate water, y'all.
Yep.
Now the head parts up here are polar, meaning charged, and are thus hydrophilic. Hydrophilic means water-loving. They love water.
Wait,
That would be Michael Phelps.
What was that?
I thought they were the same thing.
Hydrophilic means water-loving.
I thought the whole, yeah.
The whole molecule actually has two different sides to it. This half likes water. I'm sorry, this half hates water. This half likes water. Okay?
Just put the molecule.
Yeah, Graham?
What's the top half? Like, what is that made of?
Yeah.
There's a nitrogen group. It's charged.
Is that
nitrogen?
Is the orange and the white box the blue thing?
It's the blue circle.
Yeah, the orange and the white box
Got it.
is the blue circle.
Okay.
Good questions. Yes, Meredith.
Is hydrophobic like a real phobia?
Well, it's just a word meaning doesn't like water.
Oh.
This
Okay.
phobic is like afraid of.
Yes.
So is the fatty acid chain the part that's afraid of water?
Yes.
Okay.
Fatty acids don't like water. Now what happens is, when you throw a bunch of these into some water, they take on a certain arrangement, which is this arrangement here that you see. It's called a bilayer. Why do they do this? Because look, the tails, they don't like water, and the cell exists in water. Every cell exists in a water environment.
Yeah.
You might say, hey, my skin cells don't exist in water. This is air. But all your skin cells are dead. All the living cells are in a fluid environment inside your body. That's why you have to keep drinking water. Keep plenty of fluid in.
Dehydrated.
So, when when there's water around, the heads face outward toward the water, or inward, in the cell and out of the cell, toward water, and the tails huddle up in the middle away from water. There's no water in the middle part of the membrane here. There's water outside, there's water inside. Those tails are kind of protected from the water in the middle. And so you always form a bilayer, we call this a bilayer, a layer of cells on top, a layer of molecules on top, and a layer of molecules on bottom, and the water being outside and inside the cell. So this is the arrangement that phospholipids normally take if you just throw them in the water. And we call it a membrane. And it goes on and on and on. There are millions of molecules there.
Is lipids what you make soap out of?
Yeah. Soaps are lipids. Now, so you add in, if you take here's your phospholipid bilayer, and you add in proteins that act as little channels so things can go through them. And cholesterol, there's cholesterol. You see that molecule there? That's a type of fat called cholesterol. There's another one there. There's another one there. The cholesterol acts to stabilize the membrane, to make the membrane stronger. That's what cholesterol does. That's a question on your next test. Were you listening?
Yes.
Yes.
Cholesterol makes the membrane tougher and stronger. So there's cholesterol scattered through the membrane. Yes?
Good
Is
cholesterol.
this, I'm sorry, is this in a eukaryotic? Yeah.
Eukaryotic cells.
This is in the eukaryotic.
Prokaryotic cells have them too.
Alright.
Prokaryotic cells have membranes too.
Do they like differ like whatever they have in them?
Yeah, it does a little bit. But this is all you really have to know about membranes.
So what was the test question one more time?
Cholesterol,
Yes.
this molecule, helps stabilize the membrane, helps make the membrane strong. The membrane would be pretty weak without the cholesterol molecules. It would come apart too easily. Yes?
I thought cholesterol was bad for you.
It is in too much, because if you get too much, the cells don't need any more of it. It'll float and get into your blood and form solids and clog them. So you do need cholesterol, some cholesterol, but most Americans get too much of it.
Drink a good glass of wine. That goes with that.
Now, see this carbohydrate chain right here? That is a signaling molecule. It's a bunch of sugars in a chain, and it signals your other cells in your body that what type of cell this is. For instance, you have white blood cells crawling around your body, bumping into all your cells. And they recognize these chains that you have hanging off your cells. And they'll know that, okay, when they bump into this, they'll say, oh, that's fine, I recognize that chain. This is one of Drew's cells. But for instance, if he tried to take my kidney, let's say he had a bad kidney, and he took mine and put it in his body, his white blood cells might destroy it. Called tissue rejection. Because my cells do not have the same carbohydrate chains as his cells have. Do you see?
How do they not let that happen?
They don't let that happen by finding a matching donor. Somebody whose carbohydrate chains match mine. Or his. Do you see? So the carbohydrate chains that you see sticking off here are like little flags that signal what cell it is and to whom it belongs. And that's one way that your cells are kept, your body's kept clean. Your white blood cells patrolling your body can tell your cells from other cells. Video footage of the
plasma membrane is composed of a bilayer formed by two chains of phospholipid molecules. The fatty acid tail of the phospholipid molecule is nonpolar, whereas the head of the phospholipid molecule containing the phosphate group is polar. The two phospholipid molecule chains layer like a sandwich, with the fatty acid tails forming the interior of the membrane and the phospholipid heads facing the watery environments found inside and outside the cell. Cholesterol is also found in the plasma membrane. It helps to stabilize the phospholipids by preventing the fatty acid tails from sticking together. Proteins that span the entire membrane form the selectively permeable membrane that regulates which molecules enter and which molecules leave a cell. Carbohydrates sticking out from the cell surface identify chemical signals and prevent the cell from succumbing to infection.
See the proteins, well, let's go to the next one. See, the proteins act as holes. Stuff can get in and out of the cell through these proteins. See, it looks like a little hole there. If something was small enough, it could go right through. The proteins have other functions too. Some of them act as enzymes. Some of them act as carriers. Let me show you a few of these here.
It's like an orange one.
It's like a hot dog one. Hot dog.
Oh, this is cool. This shows the cell. That's a cell. And we're going to get closer. Watch this.
Between the living machinery of the inner cell and the harsh conditions of the outside world stands the cell's plasma membrane. As crucial as this barrier is, it's surprisingly flexible. Push it and watch it move.
Ooh.
Poke hard enough and it might break and begin to regroup. The lipid molecules of the membrane naturally assemble in a double layer because their tails repel water as their heads attract it. Throw in some cholesterol and a few carbohydrates, and you have the basic structure of a plasma membrane.
Isn't that cool?
Where's the
That's
protein?
awesome.
Yeah, it moves. That didn't show the protein.
Muscle.
I like the big pointer that hits the cell.
What is that?
I don't know. A needle, probably.
That was like a creepy video.
Boom, boom.
The magic of computers. I can play with it.
It looks like a what, bro? You said it looks like a what?
Needle.
A needle?
Someone said.
I thought you said a whale.
I said tramp.
Hey.
What?
What?
Another video.
A cell is separated from its environment by a selectively permeable plasma membrane. The plasma membrane is commonly described as a fluid mosaic.
This guy's got a bad
It is like a mosaic in having diverse protein molecules embedded in a matrix of phospholipids.
Okay, let me just stop. This is called the fluid mosaic model. And why is it called that? Well, fluid means movement. And none of these phospholipids are stuck in the same place. They can all move.
Flexible.
Imagine if you had 100 people standing in this room all like this. And they all close their eyes, and then you said, okay, everybody move, and then everybody starts moving and bumping into one another and going around like this. That's exactly what the cell membrane's like. It's all moving around. And it would be even cooler than that because it'd be kind of like if everybody was standing on a mirror, because there would be phospholipids below them moving too. But it wouldn't be really like a mirror because they're not following the one on top. So it'd be just movement everywhere. And so we call this the fluid mosaic model. Fluid means moving, and mosaic meaning it looks like, have you ever made a mosaic in art where there's pieces everywhere, there's different colored
What did you
pieces?
say? Fluent?
Fluid, F-L-U-I-D, fluid.
Alright, I was about to
Fluid
say that was a
mosaic.
very fluent moving. If everyone just kind of
So yeah, they got it kind of moving around here. See everything's moving. The proteins can move too. Let's see what this one is. Some of these videos are good and some aren't so good.
Are there any funny clips?
The machinery of the inner cell and the harsh conditions of
I don't think I have any funny ones.
No more Simpsons.
This shows some actual cells, and you can see the membranes.
This is a fibroblaст growing on a glass cover slip.
See the
The
membrane?
time-lapse movie clearly shows the edge of the cell, defined by its plasma membrane. At a higher magnification,
It's not
the
immature.
cell ruffles as actin microfibrils cycle inside the cell. Even closer up, you can clearly see this ruffling at the right edge of the cell.
You can see the membrane moving. Yes, Hogan.
Okay, like on the left picture, like the purple where the proteins. Doesn't protein make up muscle mass?
Yeah, you mean these?
Yeah, if somebody had a lot of muscle, then like the majority of that just be like orange in that picture.
Well, I'll show you what the structure of muscle. When you're talking about the proteins in muscle, we're talking about inside the cells. Here's the outside of the cell. The inside of the cell is most
That's
important.
where it is.
Yeah.
Nice.
Okay, so that's the membrane. It's a pretty short reading section, page 187, 188, 189, 190. Man, if we had a quiz over that, y'all should do well.
Yeah.
Oh, and
What would you quiz us over?
If we had a quiz over the reading tonight, page 187 to 190, since that's pretty short, y'all should do well. Right?
Is that a hand?
you did quiz us. What 10 questions
bro.
would you pick?
Okay, so what we're going to do now, we're going to pretend we're Robert Hooke
Okay.
and look at cork cells like we started to do yesterday. Does everybody have
Robert
the
Hooke to be the
sheet?
inventor of the microscope. Thank you very much.
Try that again.
Who wants to be
You can turn it off now.
Bud?
Thank you.
Hey, Taylor.
Tucker.
Yeah. Hey, Taylor. Watch it.
Read the what?
Watch it.